Right, section 3.4, and our goal is I will be able to determine the slope from a t-chart. So we're looking at slopes from t-charts. So obviously we're talking about linear relationships here, not nonlinear, because remember nonlinear has infinite number of slopes. So what we're going to look at is if you know that a relation is linear, you can use its table of values to find the slope. So remember that we know slope equals delta y divided by delta x. So now remember we looked at this too, that sometimes the table of values does not go up an equal amount in the x or y columns. And remember, this does not necessarily mean it's nonlinear. Okay, so what I'm telling you here with these examples, the following is table of values for a linear relationship. Okay, so I'm telling you what I'm giving you. If you graph those points, it would produce a straight line. Okay, so that would be given to you. They would give you the table and they would say, this is a linear relationship, find its slope. So let's take a look at what we have here. So we have points here, and you can see very quickly that if I did the subtracting, they aren't going up by equal amounts in either the x or in the y values. So how do I find the slope? Well, we remember I said in a moment ago that we know that slope is delta y over delta x. So we can find that with a table of values. So I'm going to switch to the writing pen. So we know that our slope can equal delta y over delta x. So when we look at our column here, we can choose, because we have our y's and x's, we can actually do subtraction. Now, the thing is, what's kind of nice about this, we can choose which numbers we want to work with. Okay, so for instance, I think that I would like to work with 5 and negative 5, because those are kind of small numbers. And I'm going to, I might want to choose this one because this end one's with a 5, and I'm thinking that. So I could choose these 2 points and not even look at that middle point if I wanted to, and I could actually calculate my delta y's and x's. So if I go over here, I can actually calculate, for instance, my delta x. And again, it doesn't matter whether I start with the 5 or the negative 50, but I think I'm going to choose negative 50 and I'm going to subtract the 5. Okay, so I'm taking my 2 points and I am calculating the change in my delta x. Now, so I'm going to put a subtraction so you can see the pattern. So negative 50 take away 5. Well, negative 50 take away 5 is negative 55. Oh, I'm not sure why I did that. Let's just go back here. Equals negative 55. Now let's go and look at our same thing. We're going to look at our delta y's. And it's important, if you notice, I started with negative 50, so I started with this bottom point. So it must mean that I start with the 105, and I'm going to subtract negative 5 from that. So I'm going to subtract negative 5. So I will put it in a bracket since two negatives beside each other. So that's the same as 105 plus 5, which I know is 110. So without graphing, I've already determined my delta y's and my delta x's. So I actually can finish finding my slope. So what I'm going to do then, and everything you see in green here is what I would expect to see on a test. Okay, so my slope is going to equal then delta y, so 110 over negative 55. Now you should recognize that that is not in lowest terms because both numbers end with a 0 or a 5, so I know at least 5 goes into them. So when we do that, well, actually, I think it goes very, very well into it. So if I take 110 and divide it by 55, I think I'm going to get the number -2. And just to prove that point, I will bring up the graphing calculator to show you. Okay, so here's our graphing calculator. So if I went 110 and divided it by 55, amazingly, it is 2. Now remember, this was a -55, so my answer is going to be a -2. So we found for this relationship the slope of -2. Now what would happen if I chose not those 2 points, but 2 different points? So let's take a look at, I'm thinking, well, what numbers do I want to work with? Well, I could choose, and I'm going to switch colors here. I'm going to change to, let's change to blue this time. So this time I'm going to use these 2 numbers to calculate my delta x and delta y. So if I go and do my delta x first, and again, I'm going to start with the bottom number, -50, and I'm going to subtract a -20. So that's the same as -50 plus 20, so I have a -30. And then if I go and do my delta y's, I would have 105 subtract 45. And again, if you have difficulty with doing that subtraction, you can actually take your calculator out, and if you do that, you end up with 60. So notice I have a different delta x and a different delta y compared to the example before. So, but I don't know if I'm going to get the same slope. So let's try it and see what we get. So again, what I do is my slope in this case, as soon as I get, there we go. So I have my delta y's over my delta x. I would end up with negative, nope, I'd end up at 60 over -30. And again, both numbers end with 0, and I should recognize that 30 is the same, 60 is the same as 2 times 30. So again, I get -2. So even though I used 2 different points, 2 different xy points, I ended up with the exact same answer. So what that shows you is you can choose the numbers in a table of value that are easier to work with. And what I find easier and what you find easier might be different, and that's fine. So let's take a look at another example, and we'll just go through it a little bit faster now. So determine the slope. Again, I have these numbers. You can see that I have some really large numbers. I have a 96 and 50s and 32s. So again, I want to choose numbers that I think are going to be easiest to deal with. Now again, I'm looking at those numbers, and because I usually don't bring up a calculator, I want to find something that I can do fairly easy. So I'm thinking if it was me, I would choose the first one and the last one, and you'll see why in a second. So if I calculate my delta x is going to be 96, take away 6, which equals 90. And if I do my delta y's between here, again, I'm starting with the bottom number, I have 50, and I'm taking away a 5, which would equal a 45. So now I can continue calculating my slope. So my slope is delta y over delta x. And that's going to equal, those are supposed to be deltas, by the way, you know, those little triangle things. They look kind of crappy. Okay, so I have 45 over 90. And that is not in lowest terms. 45 goes into itself once and goes into 90 2 times. So my slope in this case now is 1/2. All right, moving on and doing another example. Notice we're getting faster. Okay, this is my next one that I need to look at. Okay, again, I have some really kind of crappy numbers. I have some decimals this time. And I'm thinking that in most cases, you probably would shy away from that. So I'm going to choose those two because I'm assuming those are the two that you would choose. So let's again go and do our delta y's and x's. So if I go again over here and do my delta x is going to equal negative 12 minus 8. So we have negative 20. And my delta y's, I'm going to have 21, take away 6. So we know we're going to have 16. Oh, sorry, that's not right. We're going to have, get back here, pen, 15. Okay, and now I can calculate. So my slope equals delta y over delta x. Now remember, we have quite a few different formulas for a slope. So we use this formula if I have a graph. In most cases, we use this formula if we have a table of values. But if I just have 2 points, I would use that big long one with the y2s and the x2s, etc. Okay, so back to our question. So we have 15 over negative 20. So we can see we have a negative slope. 5 goes into both those numbers. 5 goes into 15 3 times. 5 goes into 24 times. So we have negative 3/4. Okay, now what we're going to do is we're going to go down to the next question. We have quite a few different ones to help us today. Now notice a couple of the points here have fractions. And again, I'm going to assume that you're going to stay away from those, but we will do, let's choose the 2 fractions because I know you don't like them. And I'll actually do it then with the other way as well. So if I look at this one first, and actually what I'm going to do is I think I'll clone this one so I can take it and do it using clone. Just going to put that over here and we'll look at this question in more detail in a second. So I am going to choose these fractions just so we have some more practice working with fractions. And let's go and do this one again. So if I look at my delta x's, my delta x is going to be negative 1, take away a negative 8. So that's the same as negative 1 plus 8. So that's a 7. And my delta y's in this case would be, I think you can do it. So we have 5 and 2/3. And I'm going to take away 3 and 1/3. So this really isn't that bad. You can do it. So I end up with 1/3 left over. So I end up with 2 and 1/3. Now, my issue is when I go to do my delta, my slope, when I have delta y over delta x, my problem is if I put it in the way it is right now, I'm going to have 2 1/3 over 7. Now that's really, really poor form because I have a fraction in a fraction. Okay, so we would have to do something different here. Okay, and for some of you, you maybe get that. That's the same as 2 1/3 divided by 7. So I'm just going to move down our little thing here. And let's see, what would we get if we actually put it like that? So we're doing a lot of reviewing of fractions here. So 2 1/3 is the same as 2 times 3 is 6, plus 1 is 7. So that would be 7/3 divided by 7. And remember, when I divide by fractions, I multiply and reciprocate the second one. Okay, my 7's are going to end up canceling out, and I'm going to end up with a slope of 1/3. Okay, now remember the 2 and 1/3? That translates to an improper fraction of 7/3. I'm going to stop the video before it gets to, I run out of time, and we'll try it without the fractions now and see if we get the same answer.